Question 12, but 2 of the short response question. An object is moving in a straight line from a fixed point. The object is at the origin initially. So we know our displacement is 0. The acceleration a in meters per second squared of the object is given by pi cos pi t for t is greater than or equal to 0 and t is in seconds. The velocity at t equals 1 is 0.5 meters per second. Determine the initial acceleration. So initial acceleration just means t equals 0 at that point. So a 0 is pi cos times pi times 0 equals pi cos 0 equals pi. Cos 0 is 1. So that's just going to be pi. Meters per second squared. Determine the initial velocity. So we know that vt, velocity, is just the integral of the acceleration. So that's going to be integral of pi cos pi t, which is, so we integrate going upwards, so cos integrates to sine. So this is going to be pi sine pi t, and then we have to divide it by the differential of pi t, which is pi. That's just sine pi t. Oh, and we need a plus c. Now we're also told in the question that at t equals 1, the velocity is 0.5. So we can sub that in to get the value of c. So 0.5 equals sine pi times 1 plus c. So 0.5 equals sine pi is 0 plus c. So c is 0.5. So our velocity equation is sine pi t plus 0.5, and we want to find the initial velocity, so t equals 0 at initial velocity. So that's going to be sine 0, because pi times 0 is 0, plus 0.5, which is going to be sine 0 is 0, so that's just 0.5 meters per second. Determine the displacement after 1 second. Okay, so first of all, we know that displacement is the integral of velocity, which means we're going to be integrating our answer from part B, which is sine pi t plus 0.5 So we know that sine integrates to negative cos. And we're going to divide by the derivative of the bracket, which is pi, plus 0.5 t plus c. Now in the question, we're told that the object is at the origin initially, which means the displacement at time 0 is 0. So we can sub that in to get the value of c. So basically when t equals 0, s equals 0. So 0 equals negative cos pi times 0 over pi plus 0.5 times 0 plus c. So this equals cos 0 is 1 and negative of that, so negative 1 on pi plus c. So c equals 1 on pi. So now we have our displacement equation, which is negative cos pi t divided by pi plus 0.5 t plus 1 on pi. And we want to find the displacement after 1 second. So S1 equals negative cos pi times 1 all over pi plus 0.5 times 1, which is 0.5, plus 1 on pi. This equals cos pi is negative 1 and negative of that, so that's 1 on pi plus 0.5 plus 1 on pi, which is the same as 0.5 plus 2 on pi meters.